Session 4.1 Measure of Center. These sessions, we want to focus the data that's in the middle. And then for the measure of the center, we could finding the median, we could finding the mean, and also the mode. First one, that will be the median. Median of some data values is the 50 percentile. Remember in the chapter 3, we talk about the percentile. And 50 percentile, that means we have a 50% data below it, and there are 50% of the data above it. And finding the median, we do have a same procedure to finding the 50 percentile. Okay, in order to find the median from a distribution, first we have to list the data from smallest to the largest. We want to sort the data from the smallest to the largest. And if the number of the data is odd, then the median is the middle observation. If the number of the observation is even, then the median is the average of the two middle observations. So they're talking about when the sample size, the n, is equal to the odd number. Odd number means like 1, 3, 5, 7, 9, and so on. Then the median will be the data in the middle. But if your sample size, the number of the data is even means like 2, 4, 6, 8, and so on, then the median will be the average of the two middle data. So you're going to find out the two data in the middle and then find out the average. Average means you want to add it up and divide it by 2. Okay, look at this example. Comparing the median of two distributions. The minimum wage of the Pacific state and the Mountain state as of April 3rd, 2014. So we have a two set of the data. One set of the data is the minimum wage for the Pacific state, and there's another data set that will be the minimum wage for the Mountain state here. So first, find the median minimum wage of the Pacific state. What does it mean in this situation? So we want to look at the data for the Pacific state here. I want you guys arrange the data from the smallest to the largest. Okay? So the smallest one will be 725. And the next one, that will be 775. And then 8. And then 9.1, and then 9.32. So we arrange the data from the smallest to the largest. And then we have the data 1, 2, 3, 4, 5, right? We have the 5 data. So the median will be in the middle. So that will be the X in here. Think about it, 2 on the left, 2 on the right. So the $8 will be in the middle, which is gonna be our median. So this means that about half of the minimum wage are less than $8 and half of the minimum wage are greater than $8. So that will be the median. Okay, number 2, find the median minimum wage of the Mountain state. What does it mean in this situation? So again, we try to arrange the data from the smallest to the largest. Just rewrite the data first. Okay, you should sort the data like this, right? From the smallest to the largest. And then look at how many data do you have? 1, 2, 3, 4, 5, 6, 7, 8. So n equal to 8, right? 8 is an even number. So we need to find out the data that is in the middle. So you could look at it. We have a 3 data on the left, 3 data on the right. So the data that are in the middle will be these 2 data. And then we're going to find the average of these two data. So what we're going to do, we want to add it up and then divide it by 2. So that will be the median. Okay, the median is going to be $7.70. Okay, number 3. Compare the results in problem 1 and 2. What does this mean in this situation? So we find the median for the Pacific state and also the mountain state. Now we want to compare their median. For the median minimum wage for the Pacific state, we find it at $8. And for the mountain state, we find it at $7.70. So that means the minimum wage in the Pacific states tends to be more than the minimum wage in the mountain state. Okay, so this is how we finding the median. Just look up the data that's in the middle. Next one, that will be the summation notation. Okay, definition, net x1, x2, x3 until the xn. This is your data set. Be some data value. The summation notation, you're gonna see that this guy, this is the summation notation. Means you want to add up all the value. The i's depends on what you want to plug it in. Here it's going to be 1, and then 2, and then 3 until the n in here. When you see the summation xi's, means you want to add up all the data values. Okay, example, segment notation. The top 5 foreign and donors to poor countries and the amounts in billions of dollars donated are certain, and let xi be the amount of foreign A listed in the ith row. So we have the data set in here. And I want you guys find out the values x1, x2, x3, and x4 and x5. So you could get that x1 means equal to 31.5, x2 that would be 17.9, x3 that would be 14.1. Okay, so just write it down. x1 equal to 31.5, x2 that would be 17.9, and so on. And then find the summation of the xi here. So means like we want to add up all the values. Okay, so just add it up. You could get 86.7. And what does it mean in this situation? So after you find the total, means the total donate is going to be 86.7 billion. Okay, so we learned this summation notation because the second part we want to learn is going to be the mean. Mean is one of the measure of the center. In order to find the mean, we'll be using like this formula. And you could see the x bar in here. X bar, this is called the sample mean. Okay, the sample mean. Sample mean will be equal to summation of xi, means you want to sum of all the data values, divided by the n. Okay, the n is talking about the number of the datas. Okay, example. Calculating the mean of some data. The minimum wage for the New England state as of April 3rd, 2014. So we have the minimum wage in here. And I want you guys find the mean of the minimum wage of the New England states. So we'll be using this formula. Again, this is the sample means notation. Okay, the x bar will be equal to your sample mean. Equal to summation of all the data value of x. So means you want to add it all up, divided by the n. So we're gonna count how many number of the data do we have. 1, 2, 3, 4, 5, 6. So it's going to be divided by 6. Okay, use your calculator to see what you guys get for the sample mean. You should get 8.03 here. Okay, so the mean for the minimum wage of the New England state will be $8.03. Okay, so you can see how to use this formula to find the mean, and you should know how to find the median as well. So look at the next example. I have the data in here. Okay, this is talking about the savings in thousands of dollars of 5 adults. So this is talking about 2,000, 10,000, 8,000, 7,000, and 14,000. First, I want you guys to use the formula to find the mean saving. Okay, check your work. Added up all the data divided by the number of data. So you should get 8.2. So this is the means, like the mean is $8.2 thousand. Okay, the mean is $8.2 thousand. And then number 2, find the median savings. So remember, if we want to find the median, we have to rearrange the data from the smallest to the largest. Okay, so we're gonna rewrite the data from the smallest to the largest. And then we're gonna count, we have 1, 2, 3, 4, 5. We have 5 data. And 5 is gonna be odd number, so we need to determine which data is gonna be in the middle. So in the middle, that will be the 8 in here, right? 2 data on the left, 2 data on your right. So the median is gonna be 8,000. Okay, number 3, suppose that the adult who had 14,000 in savings win 900,000 from the lottery. So the adult's new savings is 914,000. Find the mean savings of the 5 adults after the lottery win. So right now, we're gonna replace one of the data from 14,000 into 914,000. So my data set should be look like this. And then I want you guys find the mean for the new data sets from here. Okay, finding the sample mean. So again, add it up, divided by the number of datas. Okay, you could get this one. The sample mean will be 188.2 thousand. 188.2 thousand. Okay, and then number 4, find the median saving of the 5 adults after the lottery win. So again, this is my new data set. So in order to find the median, I want you guys rearrange the data from the smallest to the largest. And then after you rearrange the data, find out the median. Okay, check your work. So we arrange the data, and then the median will be in the middle. Again, 2 data from your left, 2 data from your right. So the median doesn't change, it's still $8,000. Okay, number 5. Describe how much the outlier 914,000 affect the mean and the median. Okay, remember what is an outlier? When we have the data, when we have some data that's far away from the majority, we consider that's an outlier, just like here. Okay, we do have the data from 2 to 10, and then we only have one really big number, 914, right? Far away from the majority. So we consider 914, this is gonna be the outlier. Okay, before we have the outlier 914, we have this data with the 14, the sample mean will be $8.2. That will be our mean. But after we replace the 14 to 914, we found out the mean will be $188.2 in here. And which is going to be really large increase. And you could see the mean is affected by the outlier. Okay, we increase from 8.2 thousand to 188.2 thousand. So we could know that outlier will be affected by the mean in here. However, for the median, we got the median is 8,000, even though we have the outlier 914 here, or we still get the 8,000 even though we don't have any outlier. So you could see the outlier did not affect the median at all. It doesn't change for the median. In here, you're gonna know when you have a data set, if you have an outlier, you don't want to use the mean as a measure of a center. Instead, you want to use the median. Okay, next one, the mole. The mole of some data is on the data with the greatest frequency. That can be more than one mole, but if all the observations have a frequency 1, then there is no mole. So the mole means like you just want to find the data with the greatest frequency. Okay, but some of the data set, it can be no mole. For example, the author surveyed his statistics students about the number of checks they send daily on average. The response on some randomly select students are certain. So this is gonna be my data set here. So think about which data has the greatest frequency. Obviously, that will be the 0, right? We do have a 0, 7, 0 from here. We only have a 2, 1, and 1, 4. So the greatest frequency will be the 0. And that will be my mole, okay? The mole is going to be 0. And for the number 2, the annual sales of the 5 best-selling vehicles in 2014 are sold. So this is going to be my data. Any data has the greatest frequency? No, right? Each data, it only appears once. So for this example, we don't have any mole. That's a no mole here. Okay, so we just learned the measure of the center, the median, the mean, and also the mole. So how the shape of the distributions affects the mean and the median, and also the mole. So if the distribution skew to the left, again, skew to the left means the left tail is longer. And if we have the distributions looks like this, the mole will be greater than the median, will be greater than the mean. Okay, but if you have the distribution skew to the right, again, skew to the right tail is longer. That means the mean will be greater than the median, will be greater than the mole. And then last one, if your distribution is symmetric, just like the normal distribution, then the mean will be approximately equal to the median and will be equal to the mole also. Okay, so that will be in the middle here. Mean equal to the median will be equal to the mole. That's it for today.